Welcome to this lecture. Here we will start a new topic called TRIAC. In the last 5 lectures, we studied about SCR, that is Silicon Controlled Rectifier. In this lecture, we will have a very brief introduction to power electronics. We will introduce TRIAC, and we will study about the construction of a typical TRIAC. Now, one field where semiconductor devices are being used is to control large amount of power which flows in a system or in an appliance. So this has led to the development of a new branch of engineering called power engineering. Now this power engineering deals with the control of power which is of 50 Hz frequency. In India, 50 Hz frequency is our line supply, the supply which we get from our power station. Now there are many applications where we need to control the power. For example, we have a ceiling fan or a table fan and we want to increase or decrease the speed of the fan, or a motor or a heater or a cooler. So previously all this control was done using electrical methods. Basically in electrical methods you would be connecting resistors in series with your load. So for example, if you want to decrease the speed of the fan, you connect a resistor so that the amount of current flowing to the fan is decreased because of the resistor. So in the olden regulators we had 4 or 5 different stages which corresponded to the 4 different speeds of the fan. So in those regulators there were 4 different resistors, and by changing the knob you were connecting the fan in series with one of the resistors, and depending on the value of the resistors the speed of the fan was determined. Now this method has 2 disadvantages. One is it does not permit us a fine control over the power flow in the system. So if you want a speed of the fan which is between level 3 and level 4, you cannot have it because in the knob you go either from 3 to 2 or 3 to 4. Whereas the newer power regulators which are made using Analogue TRIAC, you have a fine control over the flow of power. And secondly, there is a considerable wastage of power when you are using a resistor, because the resistor decreases the power by converting that power into heat. So power is dissipated as heat and is wasted as heat, which does not happen in a TRIAC. So there are 5 such important switching devices. There are silicon control rectifier, we have seen that already. TRIAC, you'll be seeing it now. Then DIAC and unijunction transistor. They can do the function of control rectification, inversion and regulation of power in a load. Now TRIAC. First and foremost, let us say why do we need a TRIAC? Because we had an SCR. What is the disadvantage of an SCR? The major disadvantage of an SCR is that it can conduct current in only one direction. That is, it can control only DC power or forward biased half cycles of a AC in a load. Now, in most of our loads, we need to control power over both positive and negative cycles. So for this purpose, this semiconductor device called TRIAC is used. TRIAC is a 3-terminal semiconductor switching device which can control alternating current in a load. TRIAC is an abbreviation of triode AC switch. This tri indicates that this device has 3 terminals, and AC means that the device controls alternating current or can conduct current in either direction. Now this figure explains the functioning of a triac. Now this control circuit made by this triac can be adjusted to pass the desired portion of positive and negative half cycles of AC through the load RL. So if you look at this figure, the current passing to the load is from theta 1 to 180 degrees in the positive half cycle. Same is the case with respect to the negative half cycle. Here in this figure we are shown triac having two terminals, but it actually has three terminals. The third terminal we have not shown here in order to simplify the circuit. Now since triac can control conduction in both positive and negative half cycles of AC, it is also called bidirectional semiconductor triode switch. Now as we have seen here that the action of a triode is not that of a rectification, so as it is in the case of an SCR. So the name triac does not contain any mention of rectification in its name. Now let us look at the construction of a triac. How is a triac made? We know that triac is a three-terminal device. Now this three-terminal device is made up with 5-layer semiconductors, 5 layers of PN, PN, PN. So triac is a three-terminal 5-layer semiconductor device whose forward and reverse characteristics are identical to the forward characteristics of the SCR, and we will see why they are identical. Now the three terminals of SCR were named as anode, cathode and gate, whereas in the case of triac it is named as main terminal MT1, that is here, main terminal MT2 and the gate terminal. The three terminals are MT1, MT2 and gate. So this figure shows the basic structure of a triac. N, P, N, P, N. So if you look at this structure, you could visualize this as two SCRs connected in inverse parallel. So this P and P, N could be thought of as one SCR, and N, P, N, P could be thought of the other SCR which is in the inverse parallel, and the gate are connected together. So this is the equivalent circuit where a triac is shown as two SCRs connected in inverse parallels with a common gate. Now as you can see in this circuit, this SCR will allow the flow of current in this direction from MT2 to MT1, and the other SCR, that is this SCR, will allow the flow of current from MT1 to MT2, that is the reverse direction of the other SCR. So in this way, in a triac, the conduction of current can take place in either direction, which is unlike that of the SCR. Now let us come to the symbol of a triac. This is the symbol of a triac. You see two diodes facing in two opposite directions and a gate. So these diodes indicate the direction of the current, and due to this bidirectional flow of the current, it can act as a bidirectional switch, and the gate provides control in the conduction in either direction, positive direction or negative direction. Now from what we have seen till now, let us note the following 4 points. The first one is that diode can conduct current in both the directions, irrespective of the polarities of terminal MT1 and MT2. So since there is no specific anode or cathode, the terminals are referred as MT1 and Mt2. Of course, to make the triac conducting, there should be a proper gate current. Now, to turn on a triac, you have to give a gate voltage which could be positive or negative. Then, as in the case of the SCR, once the triac is fired, the gate loses all control, and it can be turned off only by reducing the current to the value of holding current. This is exactly the same as the SCR. Now, triac has one disadvantage over SCR, and that is SCRs have lower SCRs have higher current holding capacities than triac. Triacs are able to allow current to flow up to or less than 40 amperes at voltage up to 600 volts, whereas in the case of SCR this value could be almost the double. In the next lecture we will look at the operation of a triac, characteristics of the triac, application of triac, and some numerical problems. Thank you.